Hello everyone, this is Fuji Research. This time I like to talk about nylon or polyamide. When you hear nylon, what do you think of? Perhaps it is something about fiber. In industry use, they can be ropes, fishing net, and so on. In commodities, they may be bags and stockings. Surely it is widely known as fibers. However, nylon is also known as material for plastic, taking advantage of its high strength and good heat resistance. This video focuses on cable ties using nylon as an example. This is one of application of cable tie seen at the tall car park in Japan. You see cable protection pipes are tied to a metal pole. This is a photo of ceiling in a JR station, showing a cable tie application. Cable ties secures cables to a cable rack. This is a similar application. In this photo, cable protection pipes are tied each other and is laid on the ground nearby rails. This one shows an application to tying cables, probably earth cables, at the mobile phone antenna station. Let us have a look at the cable ties themselves. There are many cable tie makers. Panduit Corporation and Heraman Titan are quite popular. Typically, cable ties have two kinds. They are natural and weather-resistant black. In terms of their materials, both indicate nylon 66. I heard Japanese brand of cable ties being produced in domestic Japan is SG Industrial. This photo shows SG-200, a pack of cable ties made of natural nylon 66 for indoor use. This is also a package of cable tie sold by SG Industrial. This one is of nylon 66 weather-resistant black. Well, I have checked the website of SG Industrial. I see there is an affiliated company called Sato Gosei. Now I like to check website of Sato Gosei to figure out how it relates to SG Industry. You see, this is the website of Sato Gosei. It is obvious by looking at the logo of SG that Sato Gosei probably produces cable ties for SG Industrial. Its plant is located in Higashimatsuyama Industrial Park in Saitama Prefecture. Looking at the Google map, I found the industrial park is about 58 miles away from center of Tokyo. Not too far. Let me check it out. It is for your information that Higashimatsuyama Industrial Park was once an airfield during the Greater East Asia War. Its shape is almost square. Well, let us see the scenery of the industrial park. This is the cable tie maker mentioned above, Sato Gosei Higashimatsuyama Factory, an affiliated company of SG Industrial. The cable tie maker have another plant in Tsuruoka city of Yamagata Prefecture. In the right, it is Edogawa Gosei, said to be maker of special paints and solvents. You see a factory in the right. It is S&B Food, a maker of spices. In the left, called Saitama Gakko Kyushoku, it is an unique company catering for elementary schools and kindergartens. Again in the left, it is Tsuda Industrial, having expertise in vacuum deposition applicable to paint for bottle of cosmetics. In the front left, a factory of Osho Food Service makes gyoza, a Japanese dumpling and noodles. My vehicle is running the leftover Skylark, making food for its own restaurant chains, such as Gusto. Ouchi Industry in the left makes components for automotive brake systems. Tokyo Denka is a maker of CDs and DVDs duplication. Looking at the right, you see a company named Parker Netshori Kogyo, having specialty of heat treatment for surface of metal components, such as carbonitriding. Let us check out the statistic on nylon production. Nylon is not in so-called commodity plastics mentioned in the previous video. Of information provided by Japan Petrochemical Industry Association, nylon is classified as others. Nylon is officially called polyamide, and its production share is about 2.2% out of entire plastic production. Also, polyamide belongs to thermoplastics, which accounts for 89.5% of entire plastic production. On the other hand, thermosets account for 8.5% of entire plastic production. Well, we have heard a new terminology such as thermoplastic and thermoset. What do those mean? In simple, thermoplastic is like a chocolate, which becomes soft when heated and hard when cooled and repeatable. In contrast, thermoset is like a cookie, which becomes hard when heated. So how about the molecular point of view? Saito of Monotaro has easy to understand pictures showing these two types of plastic. The left one represents thermoplastic molecular structure, in that the macromolecules are tangled, not chemically bound. But as pictured in the right, that of thermoset is different. Macromolecules are chemically cross-linked. These two different molecular structures give different characteristics on heat. The plastic introduced in the past, such as polyethylene, polypropylene, and so on, and this time polyamide, all basically belongs to thermoplastic. Now we have a question that what nylon 66 for cable ties supplied by XG Industrial is all about. Again, you should think of nylon 66, that is Du Pont brand of polyamide 66. Looking at the website of SG Industrial, it appears Leona 1402S as a cable tie material. Well, let us check which chemical company produces the Leona. In website of Japan Petrochemical Industry Association, you see polyamide 66 Leona, and it was produced by Asahi Kasei's Nobeoka plant in Miyazaki Prefecture. So looking at the website of Asahi Kasei, I found 1402S as one of Leona grade. Let us dig in. We are able to see datasheet of Leona series. This time I skip each data such as strength, but it is obvious there are two columns saying dry and wet under 1402S. This would not often appear for other plastics. Why does this come with polyamide? This is special to polyamide because it absorbs water due to having amide bonds in the molecules. This influences properties such as strength, dimension, and so forth. Even this might be a negative characteristic. However, polyamide plastics are used for a variety of products. How about looking into what the polyamide really is from a molecular point of view? There is a good explanation in Asahi Kasei's website. Literally, polyamide means thermoplastic consisting of many molecules having an amide bond. So what does amide bond? As the illustration said, it is a bond having a carbon to oxygen, nitrogen to hydrogen, and the bond of the carbon from the earlier, and the nitrogen from the later. Then we should take a look at the case of polyamide 66. According to this illustration, making polyamide 66 requires hexamethylene diamine and adipic acid. When the two chemicals are mixed, two hydrogen and one oxygen are bound to bear water as a byproduct, and the rest of the chemicals connect, and this reaction repeats. The N in the illustration refers to how many the units are repeated, and thus it means polymerization degree. It is amazing finding such a complicated reaction, isn't it? Lastly, let us check origin of raw material of polyamide 66. As in the illustration, it goes many processes, but tracing upstream, it is naphtha. It is clear that naphtha is the key chemical. Well, when talk about polyamide, there is a story no one can avoid. That is about the chemist named Mr. Carothers, working for Du Pont in the US. He succeeded to make a polyamide fiber in 1935, and it was the first in the world. The fiber was named nylon. His contribution was great. However, he put an end to his life by himself in 1937. He might have mental illness then. Folks, take care.